Next one on the list is WireGuard. WireGuard is a communication protocol that implements virtual private networks or VPNs. It's fast, relatively easy to set up, and considered by many to be the safest VPN out there. We will configure it in a VPN server configuration as described in this section of the ArchWiki WireGuard article. Let's take a quick look on what we will set up. WireGuard server will be on my VPS, and clients in my case will be my laptop and my phone. That means that all peers, as WireGuard calls them, will get an IP from the same private subnet. VPS will be 10.100.94.1, my laptop will be .11, and my phone will be .12. And that will allow us to access anything inside this private network through this WireGuard tunnel. For example, we'll have a client, my laptop, with WireGuard configured. We'll have GitLab running in a Docker container, and we'll have traffic as the only entry point for all HTTP communications. Traffic will have a rule, a so-called middleware, that allows only certain IPs to access GitLab, one of which will be 94.11. Now, let's say that we've configured DNS for gitlab.do-p.com to point to the public IP of our VPS. In WireGuard config here on laptop, we'll say that for that IP, our laptop should use the WireGuard tunnel. It goes like this. We type in gitlab.do-p.com on the client. It resolves to this IP. Our network packet then uses the WireGuard tunnel as a route to reach the VPS, and since this is HTTP protocol, it is greeted by traffic. Remember that we'll configure traffic as an entry point for all HTTP and HTTPS communications. Traffic sees that source IP is 94.11 and that it is asking for gitlab.do-p.com. Traffic then checks the IP whitelist middleware for that domain, sees that this IP is present on the whitelist, and lets us through. That's enough for a quick intro. I'll talk more about it after we deploy traffic and some services. I'll start by creating necessary directories for this role, so WireGuard with subdirectories tasks, files, and handlers. And now I will generate all private keys, their public counterpart, and pre-shared keys for additional security. These are not necessary. To generate keys, you'll need to install CLI tools for WireGuard, which on macOS I did with Homebrew. For other installation methods and operating systems, check the official documentation at wireguard.com/install. Go to the Files subdirectory and run all these commands with your own file names. When done, you should have something like this. So server's private and public key, laptop's private and public key, maybe your phone's, and pre-shared key for each of the connections. So VPS to the laptop and VPS to the phone. Let's create a server WireGuard config now by opening vg-do-p.conf, also in Files subdirectory. You define an interface by giving it an address. This will be the address VPS will get in this WireGuard network. You define a listen port and you provide a private key. That is the key you generated earlier. In my case, contents of do-p.key. Then you define as much peers as you like in this format: public key, pre-shared key, and an IP this peer will get. Save the file and open main.yml in tasks subdirectory. First, using the pacman module, I'll install WireGuard tools. This package will provide me the WireGuard systemd service file. Then I will copy the config for the server we've just created to the etc WireGuard directory on the server. And I'll also add a handler to restart this service if there is a change made to this file. And finally, using the systemd module, I will start and enable this service. Save the file and open main.yml in handlers subdirectory. Nothing new here, it will restart systemd service if there was a change made on the server. Save this file, and the next thing we'll do is we'll create client configs. In my case, a laptop and a phone, and we'll make a modification in our IP tables. We need to allow access to the port we've defined in the WireGuard server config. Open laptop.conf in files subdirectory, and it's similar to the server config we created previously. So address is .11 this time. Private key are contents of laptop.key, and you can specify a custom DNS server to use when this WireGuard tunnel is active. And then we add a peer. Public key is public key of the VPS, so do-p.pub. Pre-shared key is do-p-laptop.psk. In allowed IPs, you provide IPs which you wish to access through this tunnel. For now, I added VPS public IP, its WireGuard IP, and its additional loopback IP. And finally, you give it an endpoint, IP and port of where that peer is listening. Save the file, and let's do the same thing for the phone client. So open phone.conf also in files subdirectory, and this one is pretty much the same. Address is now .12. Private key is the contents of the phone.key this time. And for the peer, public key is the same because it's the same peer. Pre-shared key is different though, it's do-p-phone.psk. Allowed IPs is the same, and endpoint is the same. Save the file. I'll add WireGuard to the setup.yml. I'll comment out certbot role, save the setup.yml file, and in virtual environment run Ansible playbook. Ansible has finished successfully, and we can confirm that if we go to the VPS and check the status of this service. And as you can see, it is currently running and it is enabled on boot.